So I'm not just talking about any point on that circle. I'm talking about that one point that defines the center of the circle. So when we talk about the center of a circle, we'll use HK. When we talk about the vertex of a parabola, we'll use HK. HK is that very specific primal point in a particular graph, like a parabola or a circle. And what letters shall we use for radius? Let's be daring and use R. And here we go. If I know the center of the circle is HK, and I know its radius is R, here's the equation for the circle. It's x minus the x of my center, which is h, squared, y minus the y of my center, which is k, squared, equals the radius squared. That's 3 by 5 part stuff right there, ladies and gentlemen. That is your general equation for a circle in standard form. The center, HK, radius of R. Well, you know what's coming, don't you? Here's a center and here's a radius. What's the equation for a circle? Center is 5, 2. Radius 7. The question will be, what's the equation of that circle in standard form? I know it's going to be something squared plus something squared equals something. What goes in the first something? Very good. It's x minus whatever h is, and 5 happens to be my h, so x minus 5 squared. And the second parentheses, y minus 2 squared equals 7 squared, or 49. Typically be written 49. Hey, what does that remind you of? Something squared plus something squared equals something squared. Absolutely. This is an other equation that takes its foundation from the Pythagorean theorem. Pythagorean theorem gives rise to the distance formula. The distance formula gives rise to the equation for a circle in standard form. All goes back to old Pythagoras. And some of you are probably wondering, hey, do I go ahead and flesh this guy out? Do I go ahead and multiply x minus 5 times x minus 5, and then multiply this guy out, get all my terms together, and get all my numbers? No. Leave it like that. Here's one. If you do all that stuff and combine all your terms, all of a sudden, your center is gone. You know, what's the center of this circle? Don't know. It's not there. What's the center of this circle? It's obvious. 5, 2. It's just sitting there looking at you, right? So as long as you leave it in this form, the center is visible. And the radius is visible. Just take the square root of this guy. Got my radius. Do another one. It's going to be something squared plus something squared. What goes in my first parenthesis?
X plus 1.
Hey, how'd you get x plus 1?
Negative times negative
Yeah.
positive.
Did you notice it's x minus whatever h is? H happens to be negative 1. So x minus a negative 1, that's redundant. That's the same as x plus 1. And my second parentheses?
Y minus.
Absolutely. And equals 3.
3.
How'd you get 3?
Because the square root times a
That's
square
right.
root.
It's the square root of 3 squared, which as you know by now is just 3. Any questions? So basically, ladies and gentlemen, when you're looking at the equation of the circle in this form, to find the center, what do you do with those numbers? Change the sign, take their opposite. Okay. So the center is -1, +7. Right? We got that kind of relationship down. Why? Because the formula says x minus, y minus. One more and then we'll go the opposite direction. It says R equal 12, is that what's getting?
No, talking about the semicolon, looks like a J.
Oh, that's a semicolon. That still looks like a J, doesn't it? Slash, radius is 12. Center is the origin, radius is 12. Hey, anybody got it?
X minus 0.
X what? X minus 0 squared. And I'll bet you, ladies and gentlemen, that's not how it's going to show up. What is x minus 0? I'll bet it's going to show up like x squared plus y squared equals 144. That's how it's going to show up. Because x minus 0 and y minus 0 is just x and y. So I have a general observation here. You ready for a general observation? Always has a particular application when we come to testing time. General observation, anytime you have an equation that starts out x squared plus y squared equals a number, it's a circle with center at the origin. X squared plus y squared equals a number, a circle with center at the origin. Every single time. That implies a circle with center at the origin. All right? General observation. Work separate time. All right, let's go the opposite direction. We started out giving a center and a radius and find the equation. Now, let's get the equation and come up with the center and the radius. You do that. I'll say, what's the center? What is the radius? Hey, what's the center? -5, +3, right? You just took the opposite of these two numbers because it's x minus and y minus. So it's -5, +3. And what's the radius? Very good, because that's r squared, right? So the radius must be 5. Okay, try another one. Two zero, very good. And the radius is square root of 10. This is the radius squared, so take the square root. Square root of 10. What's the center? Very good. Center is 0, 0. The radius is? Which is?
1.
Yeah. So you should be able